Hey class, Dr. Selby here. I just want to review how to name the simplest type of ionic compounds. And when I say simple, I mean that there's only one type of metal and one type of nonmetal. And the metal has a predictable charge obtained from the valence rule. So recall from our last studies that group 1A metals, when they react, they form a +1 charge because they have one valence electron. Group 2A metals form a +2 charge because they have two valence electrons. So when they lose those two valence electrons, they become like the nearest noble gas. And then aluminum is also predictable. It's in group 3A and it has three valence electrons and forms a +3 charge. Looking at the nonmetals, group 7A nonmetals contain 7 valence electrons. To be like the closest noble gas, they gain 1 electron from the metal and they form a -1 charge. In group 6A, there's 6 valence electrons, and to form an octet, they gain 2 valence electrons to form anions with a -2 charge. And then in group 5A, they form a -3 charge to have an octet. The names of the cation in an ionic compound is always the same as the metal name in these simple cases for these predictable cations. And then the name of the nonmetal always gets an IDE ending. So nitride from nitrogen, phosphide from phosphorus, oxide from oxygen, sulfide from sulfur, and so on. And in naming these, which is pretty simple, we're just going to list the cation name, which is the same as the elemental name, and then the anion name that has an IDE ending. So, for example, here we have cesium, here we have potassium, here we have lithium, here we have magnesium, and here we have calcium. So just naming the cation names, we have cesium here, potassium, lithium, magnesium, and calcium. For the anion names, chlorine becomes chloride. Oxygen becomes oxide as an anion. Nitrogen becomes nitride. Chlorine again becomes chloride. And oxygen again becomes oxide as an anion. And that sums up how to go from a formula for an ionic compound with predictable ions, the simplest type, into a name. How do you write ionic formulas if you're given a name for this simple type of ionic compound? Well, there's some things that you need to remember. Is that ionic formulas contain cations and anions. The charges on the total charges on the cations, like how many you have with how many anions you have, has to balance to 0. Their overall charge neutral. And then we use the lowest ratio. So for example, if you have something written like this, that's not correct because you could divide both these by 2 and simplify it. So again, total positive charge has to equal total negative charge. And then you always write the symbol of the metal first, the cation, and followed by the nonmetal, the anion. So let's go through some examples in how to write these formulas correctly. And looking at a periodic table, what I would do is look at what group number the cations are in, and then put the charge on the cation. And so, for example, potassium we know is a 1A, it forms a plus 1 cation. Lithium is in 1A, it forms a plus 1 cation. Barium is in 2A, it forms a plus 2 cation. Calcium is in 2A, forms a plus 2 cation. And aluminum is in 3A, so it forms a plus 3 cation. And then looking at the anions, again from the periodic table, we're looking at what group they are in, and then how many valence electrons is the same as that group A number, and they're going to gain the number of electrons, which would give them a total of 8 to be like the closest noble gas. So chlorine, which is in 7A, will gain 1 to become chloride and be like the closest noble gas. So it'll be Cl minus because it gains 1 electron. Oxide is in 6A, and so it'll gain 2, so it'll have a minus 2 charge. Sulfide's in 6A, and so it'll gain 2 and has a minus 2 charge. Nitride is in group 5A, so it has 5 valence electrons. It wants 8, so it'll gain 3 electrons to become N with a minus 3 charge. And then again, sulfur is in 6A, gains 2 valence electrons in electron transfer reactions to become S2 minus, or the sulfide anion. So now we need to write these for charge balance. And right now, if we look at this, that has a plus 1, that has a minus 1. So charge is balanced in a 1-to-1 ratio. So it's just KCl, one of each. With lithium oxide, here we have a minus 2, and here we have a plus 1. So to achieve charge balance, we need 2 lithiums to create a total of a plus 2 charge coming from the cations. So this is going to occur in a ratio of 2 lithiums for a total of plus 2 charge for every oxide anion. In barium sulfide, barium has a plus 2, sulfur has a minus 2. So those are going to occur in a 1-to-1 ratio, and that balances the charge. So it's just BAS. In calcium nitride, calcium has a plus 2 and nitride has a minus 3. The lowest common multiple between 2 and 3 is 6. So we're gonna want, I'm gonna do some work down here at the bottom. If I take this calcium and have 3 of those, 3 calcium plus 2, the total charge would be plus 6. And for the nitride ion, if I have 2 of them, the total charge coming from the anions would be minus 6. So the ratio is going to be 3 calcium cations to 2 nitride anions. So here we have Ca3 and 2. For aluminum sulfide, we have plus 3 on aluminum and minus 2 on sulfide. The lowest common multiple between 2 and 3 is 6. So we need a total of a plus 6 charge coming from the aluminum and a total of a minus 6 charge coming from the sulfides. And to do that, I'm going to do some work down here. We're going to have 2 aluminum cations for every 3 sulfide anions. So the total charge here would be a plus 6. And the total charge here would be A3. That concludes this video. In the next video, I will talk about ionic compounds that contain transition metal elements that have variable charge. I hope this video was helpful. Sorry about my dogs barking and whining in the background. You have a great day. Bye.